In this presentation, we're going to look at confidence intervals for proportions. So let's just read the question here. In a random sample of 200 policies from a company's private motor business, there are 68 female policyholders and 132 male policyholders. Calculate an approximate 99% confidence interval for the proportion of policyholders who are female in the corresponding population of all policyholders. Okay, so it's a straightforward enough question, really, but what it's sort of an important point to pick out here is that you should read the question carefully, because later on you will be dealing with two populations and you'll be asked to compare the difference between the two. So it's essentially what happens is they might sort of ask you a question that sort of tries and tricks you into a different type of question that you're not asked at all. So essentially it's a very straightforward question. In this particular instance, what we were asked about is the female policyholders. Okay, so we have 68 out of 200 policyholders who are female. Okay, so our general structure of a confidence interval here is as follows. I've dealt with this before, so I'll sort of skim through it very quickly. General structure of confidence interval, point estimate plus or minus quantile times standard error. Our point estimate is the sample proportion of policyholders who are female, and then in this instance it is 68 out of 200, which gives us a point estimate of 0.34, 34% in other words. Okay. The interval size, which we are told in the question here, is 99%, and we have a sample size of 200. Okay. As always, it's good to point out that we consider this a large sample size, depending on what your threshold is of what you should consider a large sample size. In my case, I would sort of go n greater than or equal to 30, but different lecturers, different courses might have a different threshold. And we are able to assume that the sampling distribution is approximated by the normal distribution, which is good. So that means we can move on to our quantiles. Okay. So in this particular instance, we are asked for a 99% confidence interval. Okay, so we would use from the tables or whatever format you have for calculating the quantiles. We are looking for the 99.5% quantile. Okay, and that gives us 2.576. So 2.576 is our quantile. So we'll move on to the next part here, the standard error. The standard error is a straightforward formula. Usually you might see it in tables or at the back of the exam paper, and quite often you might have it learned off by heart. Sorry, I just had to pause for a cough there. So anyway, our point estimate times the complement of the point estimate, that is 0.34 times 0.66, and what we do is divide that by our sample size, 200. So 0.34 times 0.66, that gives us 0.2244. Divide that by 200, and we get 0.001122. Okay, and then we get the square root of that, which is, I make that out to be 0.0335. Okay, how you manage rounding error might influence what the number you end up with, but you should end up with a number close to that. Anyway, so moving on, you should actually, in a lot of questions, you should get between, let's say, between 0.02 and 0.06. Okay, in a lot of the realistic questions. So that is in our range of values. Now, so where am I? Let's go back to the end here. So our 99% confidence interval is 0. So essentially, I'm just putting it all together now. 0.34 plus or minus 2.576 times our standard error. We multiply that out. We get the standard error times the quantile. We get 0.086. Okay, and we add or subtract that to the point estimate. We get 0.254 as the lower bound, and the upper bound is 0.426. So 25.4% to 42.6%. Okay, so that is our 99% confidence interval. Whoops. So we'll leave it there.